welcome back to SOH, Best Office Hours, because you are part of them. So this is 2023, AP Physics 1, and the first problem. And we have oscillations. We have a card that oscillates between two positions, minus L and L. And very important, friction is negligible. In this case, we can use the physical principle of conservation of mechanical energy. In practice, this means that we can sum up the kinetic and the potential energy. There is no gravitational potential energy here that matters because it doesn't change, it's horizontal. So you have kinetic plus potential, I was saying that, elastic, right? The elastic potential is equal to a constant. Okay, so how much is this constant? We can go here when we see that for k equal to 0, mu elastic equals 4 joules, and then we get that this is the value of the constant, okay? There are units, which is good, but we don't use them really. So k plus mu e is going to be 4, which is basically a line. And also when the elastic potential is 0, then what do we have for the kinetic? It's 4, so here. So we have proven that. So this is the principle that we are using, conservation of mechanical energy. This is the equation. We have found the constant, and yes, we have also derived that should be 4. Well, that's great. What happens next? So, there is something that is dropped on top, but it continues to oscillate from minus L to L. Okay, and then we have these two masses, and we have to compare the frequencies. So for that, you have to remember that the frequency of the oscillation of simple harmonic oscillations is this formula, where k is the spring constant, and m is the mass that oscillates. This is the mass that oscillates. So this changes, right? Because first we have this guy oscillating, but then we have both of them oscillating. So the frequency 2 is going to be the same k, the spring didn't change it in the collision, we didn't hear anything about it, divided by 4m naught. And with a little bit of algebra, we can put this thing out, right? The 1/2, and you get this, and this is the frequency 1. So you get f2 equals to 1/2 of m1. Just in case, let's write what they ask, which is the ratio, right? So 1/2, just in case. It's the same thing, but just in case. So it's half of the frequency, okay? Cool. Yep, nothing else. Now, the dashed line in figure 4, yes, is the same, right? These two are the same. And it's after the collision, which may look like a little bit like, how is it? There's been a collision. Okay, let's remember what this line was. This was this thing, right? And this is the kinetic energy of the system. And this is the potential energy. Okay, the potential energy has not changed because during the collision, no one said that anything happened about the spring. And it happened also at the maximum elongation, right? But anyway, it was a vertical collision and nothing changed here. So this should be the same. What happens with the kinetic energy? Well, the kinetic energy, the collision was vertical, so yes, so the collision was vertical, perpendicular to the motion of the cart spring system. So in this case, then the forces did not affect the motion, the horizontal motion of the system. So therefore, the kinetic energy continues to be the same. There was nothing changing the x value of the speed. So this continues to be the same. That's the main reason. So that's why it's the same, because the collision was vertical, perpendicular to the motion of the cart spring system. Okay, that's it. That's all what you need to know. Now, what happens next? It says after the block is dropped into the, consider only the cart and the spring system. What does it mean? They are together. They're all together, but only this system. Okay. Well, we know from B, that's very important, that K plus UE equals 4 joules. But what is K? K is K of the cart plus K of the block, right? They move together in the sense that this is 1/2 of m, I don't need this V naught, plus 1/2 of 3m, okay? We have this, right? So, and this is total, it's going to be this, of course. They have the same speed, they move together, right? They move together. So it would be nice to know how much is K cart in terms of K total. K total is this guy. So this is 1/4. You see, you divide by 4, 1/4 of K total. Okay, K total, or this K here. In other words, you can write K as 4 times K cart. At any time, This is 4 times, right? This one. At any time. So this equation that is all the time true can be written like 4 times K, the kinetic energy of the car, plus the potential energy equals 4. So you get a new equation, which is K cart plus, you could write it like this, or equals to, divide by 4 basically, 1 minus this. So when this is 0, so let's say here, then K cart is 1. So here you have 1. But when the elastic energy is 4 joules, because it can still be 4 joules at the extreme, right? Then the K cart equals then 0 here. So you have to join these 2 dots. And oops, well, this is not a good line, right? Let me just do it better. Anyway, it's because the tablet, is not straight. Anyway, that's the equation, and that's the solution. It's interesting. This problem is interesting, especially because you have to do this relationship here, but I still use that this is the true conservation of energy because the motion was vertical and did not change the horizontal one. I think it's a neat problem, and well, hopefully, you will get something similar, and you've learned about this important fact about the vertical motion does not change the horizontal one. Okay. Bye. Thank you so much. See you next time. Let's do this.